All right, so I hope you've had the chance to at least do direct substitution, never not first on 16D. So again, notice we have two variables here. The variable that's underneath the limit, which is h, that's going to be the one we define as our variable right there. And so everything else, namely the x, we're going to treat like a constant while we're evaluating the limit, okay? And then we can let it float as a variable again in the end. So when we get to the next section, you'll be seeing a lot of this type of limit. We'll be setting them up ourselves first and then evaluating them. And you might actually see this and recognize it kind of looks like my favorite problem from pre-cal, but with the trig function. And that's because it is. So if you do plug in, you get sine of x minus sine of x, which is 0 over 0. Okay, so the bad guy in the bottom is h. He's the guy we need to divide out. There's two terms in the top. Neither one of them have a common factor of h. So we're not going to be able to use the Fado method. Sledgehammer, I don't know. Maybe there's nothing really you could do. Can we distribute the sign? Can we call that sine of x plus sine of h? That'd be great and wrong if we could do that. No, we can't do that. So there's no complex fraction. There's no radicals. But that sine of x plus h needs to be expanded. Man, if only there were a way. Is there a way? Yeah, there is. Okay. And I know you all remember this from pre-cal, but bear with me here while I review it. Sine of a plus or minus b. Okay, remember the way we remember this is sine is what? Selfish or selfless? Selfless. Selfless sine. Okay? Rachel's challenge rock star. It's my identity, so the law requires I go first. So it's sine of a. And then cosine goes. You're dang right, I've been waiting. Sine's like, chill out, I was going to let you go anyway. It's all about taking turns, dude. Right? And then sine times sine. Remember that? Sine times sine. So plus, minus. I don't know if Miss Lincoln said that. Sine times sine. So you keep the sign every day. and now it's sine of the second one, cosine of the first. There you go. So that's the composite identity. And then cosine, selfish, bloviated cosine, a plus or minus b is cosine, cosine, right? Me. I go first. Cosine a, cosine b. And the cost for being such a bloviated egoist is to change the sign. Okay? So now it's minus plus, and then sine's like, chill out. There's plenty of identity for all of us. I don't mind going second. We're going to get to the red light at the same time. And there it is. Okay? So those do show up. It's probably worth peeking at those again and putting them back into your mental hard drive. So that's what we're going to do here. So working down here, we got the limit as h goes to 0. So that's going to be sine of the first, cosine of the second, sine times sine, plus sine of the second, h, cosine of the first. All right, and then we got this minus sine of x that's still hanging out there, and all of that is all over h. Okay, so that was awesome. Now, does anything cancel? Do we have like terms? Does anything go away? Bummer. No, nothing goes away. We're still trying to get this h to go away. And do we have any factors in the top that even have an h in it? No, not factors, right? The h's are angles. So here's what we're going to do. Let's do this. I do see a common factor. I see a common factor of sine. Let's get those guys together. So when you have multiple terms in the top, you could put any combination of terms over the entire denominator. So if I take those two, the first and the last, and I factor out the sine of x, I'm left with a cosine of h in that first term and a minus 1 in the last term. Yes, yes? And I'm going to put all of that over h. Plus, that other term in the middle that I haven't messed with, I'm just going to leave that as sine of h times cosine of x all over h. So again, you could do this. You don't have to put every term over the denominator. You could take any combination of terms and put them over the entire denominator. Okay, so why is that important? Well, what's our variable in the limit here? Yeah, it's h going to 0. So what do I know about this factor group right here? That goes to 0, right? We memorized that. So sine of x is a constant, remember? So we got sine of x times 0. plus, and then by the associative property over here, what do I know about sine of h over h? It goes to 1. And then cosine of x would be treated like a constant. So we can evaluate both of those by those things we memorized. And so now we get 0 plus cosine, which is cosine of x. And that's the answer. So when we get to chapter 2, you'll actually be memorizing. It turns out that cosine of x is the derivative function of sine of x. And that's what this gives us. This gives us the definition of a derivative of a function. And so we'll memorize that so that next time we see this, we'll be like, oh, that's just the derivative of sine, and the derivative of sine is cosine. And we can skip all those identities, okay? But right now we're just practicing evaluating limits. Cool. By the way, what's the derivative of sine? Cosine. It doesn't hurt to memorize that ahead of time, even though you really don't know what a derivative is. All right, and the last one here, the last one of this section. We're approaching pi thirds. So if I use direct substitution, goodness gracious, cosine of pi thirds is a half. 1/2 squared is a fourth. So I got 12 times a fourth, plus cosine of pi thirds is a half. A half times 2 is 1, minus 4. So I get 3 plus 1 is 4 minus 4. I get 0 in the top. And in the bottom, I get 4 times a half is 2 minus 2 is 0. Wow. That was fun just plugging in just to get 0 over 0. I do get 0 over 0. Now notice we're approaching pi thirds, not 0. So we're probably not going to be using our identities that we memorized. So we have to have some other method. Anybody have an idea? Yeah, very good. Factoring. And first thing I noticed, just to kind of help myself, prime my pump a little bit, I noticed I could factor out a 2. Now, if you don't want to show factoring out the 2, I know y'all are BC kids. Just you can divide out a 2 from every single term if you want. That's going to be 6 cosine squared plus regular cosine minus 2 all over 2 cosine of x minus 1. It just saves a little bit of writing. Just make sure you take out the 2 factor from the coefficient in all 5 terms. Okay. And now we plug in again and we'll still get 0. So speaking of factoring, if you notice the top, it's something squared plus something plus a constant. Where else have we seen that? It's a trinomial quadratic, right? It's a quadratic trinomial, but instead of just x squared and x, it's cosine squared and cosine. Well, it's going to work the exact same way. So this is actually a Fado problem, a factor and divide out problem, but its functions are cosine. So let's see if we could factor the top into the product of 2 binomials. Oh, and by the way, the bottom is 2 cosine x minus 1, which is kind of like 2x minus 1. Guess what one of the factors in the top more than likely probably is? 2 cosine x minus 1. Yeah, I'm betting. Because we got a 0 in the top, it's probably because of that factor, and this problem was designed probably to divide out. So that can help you force the other factor. If I have a 2 then, and I need to get a 6 cosine squared, that has to be a 3 cosine of x. And if I need a negative 2 on my constant, and I currently have a minus 1, I need a plus 2. And now you can just check the inside outside. The outside is going to be 4 minus the inside is 3. That gives you 4 minus 3 gives you 1. So yeah, it factors. Factors is cosine. And now, those divide out, and so we can use direct substitution. So we get 3 cosine of pi thirds plus 2. Free response, you're done. Rocking and rolling. Again, once we plug in, we don't need to write the limit. But of course, cosine of pi thirds is a half, so you get 3 halves plus 2. You can also stop there on a free response. But 2 is how many halves? 4. So you get 4 plus 3. You get 7 halves or 3.5. So that would be your multiple choice answer more than likely. All right, so factor, factor, factor. Now, you might see sine squared and sine or tangent squared and tangent. It would kind of be the same thing. It also happens with e to the x a lot as well. So if I take the same idea here and I write that as 6e to the 2x plus e to the x minus 2, that would also be a quadratic trinomial. Okay, but instead of x, we have e to the x. All right, by the way, e to the 2x is the same as e to the x quantity squared. Because when you raise the power to a power, you multiply. So it's a squared term. So that would factor also very similarly into 2 e to the x minus 1 times 3 e to the x plus 2. So trying to increase your awareness of factorable things like that. They don't always have to be plain old x. But what matters is that the exponent on one of those is twice the exponent on the other one. Okay? All right, so that takes care of 1.4. Lots of wonderful, awesome algebra and even some trig there at the end. Any questions on anything from 1.4? It's a good review of all the other methods, of all the other sections. All right. Yeah, there's a worksheet for it, so make sure you give it a go. Yeah.
So for the absolute value of things, you want us to put it over like if it's linear, put it over a linear.
Yeah, you don't have to do that as long as you associate it like that. So like if we have x squared all over like 2x minus 10 all over, and let's say that this is like x minus 5, and you factored it to get x plus 4. Okay, and we were taking the limit as x went to 5, something like that. All right, when you plug in, you're going to get 0 over 0. What's causing the 0 in the top? It's this piece. What's causing a 0 in the bottom? It's that piece. You don't have to physically rewrite it and put one directly over the other. That's not required. It's one term. So you could just use the associative property of multiplication, and, I mean, you can just mentally lasso those together like that. That's Jumpman right there. It is linear over linear. And so in order to use Jumpman, let me put this from the left-hand side this time. To use the Jumpman rule, you do need to isolate that. So everything else that I didn't lasso, you're going to plug in a what to evaluate it? A 5. So you're going to get 25 over 5 plus 4, which is 9. So I take care of that piece. And then the Jumpman piece, that's the only piece then that you can plug in something like what? 4. Let's go ahead and do that. 4 times 2 is 8. 8 minus 10 is negative 2. But the absolute value of negative 2 is 2. And then we plug a 4 into the bottom yellow piece. 4 minus 5 is negative 1. So now your final answer is negative 59. Yeah, so that's all. If the bottom were factored, like x squared minus x minus 20, you would need to factor it into x minus 5x plus 4 so that you can group those two linear things that are causing 0 together for the Jumpman rule. Okay, but I'm not going to make you physically rewrite it. I mean, that's entirely up to you. You wouldn't need to do that on a free response either. Okay, just do what you need to do to make yourself successful. Every line that you do write, though, that still has a variable needs a limit in front. Okay, so just keep that in mind as well. Cool. Any other questions? No? All right. Here's what we'll do then. I don't think I'm going to get too far into 1.5 for the test tomorrow. In fact, maybe I won't even do anything. So I'll give you the rest of the time now until lunch to work on 1.4 worksheet because it's pretty big. There's lots of good things on there. And then after lunch, we'll talk about what the test looks like, give you some resources, and maybe work some more practice problems if y'all want. So we'll save 1.5 until Monday. Yeah? Okay.